Question 18 asks you to draw the hydrolysis mechanism of stearate basically being cleaved off of a triglyceride. All right, I'm not going to draw the entire structure for you. You should be able to figure out the structure of a triglyceride with stearate fatty acids on it. All right, so I'm just drawing you the relevant portion. So, this portion up here, that's the glycerol. The portion down here is one of these fatty acids. All right. And so how does this occur? Well, we're doing a hydrolysis reaction, so we're going to use water to break bonds. And specifically, we're trying to break the bond right here between the glycerol and the fatty acid. All right, so a water molecule, to begin with, is a pretty poor nucleophile. Right, it does have lone pairs of electrons, but it has no net negative charge. So we're going to increase its negative charge by deprotonating it. That's our first step. All right. Once we've deprotonated it, now the hydroxide that's produced is a great nucleophile and can readily attack the carbonyl carbon here. And now we end up with 5 bonds to this carbon. We want to break the weakest one, which is going to be the pi bond of the double bond to the oxygen here. So we push the electrons up onto that oxygen. All right, so the state that we're at right now, let's draw this. All right, it looks something like this right now. So we have this alkoxide intermediate, this tetrahedral intermediate right now. All right, so at this stage, right, this alkoxide can collapse back down, and we now need to lose a bond because we've once again created 5 bonds to the carbon. So we could lose the hydroxide here, but then we're just right back to where we started. So we haven't done anything productively. But instead what we're going to do is we're going to lose the bond to the glycerol here. All right, so these electrons could go over here to the oxygen like this, but then we have a negatively charged oxygen leaving group here with no resonance stabilization. So instead, I'll have it leave and get protonated right away, just with a free proton in solution. And the end result now is that we have the carboxylic acid of the fatty acid and the glycerol as 2 separate molecules.